Hola, how are you doing? So my name is George. I've recently moved to Barcelona since now 2 months, and I love it. The city is wonderful, and you guys are really very lucky living here. So today I am going to talk about Nich syndrome. Which of you know what Nich syndrome is? Okay, not a lot. So I call it Nich. I don't know how it's pronounced. I call it Nich because it sounds disgusting, and I think that's how it should sound. So Nich stands for not invented here syndrome. So it's the compulsion of the developer, of the programmer, to always use software that he develops, and not anything that is not developed by him. We don't want it. So that can also apply to companies. Maybe a company, for legal reasons or for security reasons, does not want any software outside of the company. It needs always to use its own software. So that's Nich syndrome applied to a company. But it also applies to people. People can also suffer from this syndrome, if you can call it a syndrome. And they only like to use their own things and only use their own code. So why am I talking about Nich syndrome? Because in this project that I am going to be talking about, basically everything was invented here. Like it's exactly Nich syndrome in the extreme. I didn't want anything else into my code because I was aiming for performance. So I want to be sure that nothing was slowing down my code. So my idea was to so I used Nich syndrome as a tactic, basically, applying Nich syndrome as a programming tactic. So the idea is that when you want complete control of your code, you have to invent it yourself. So there are some pros, some advantages to that, some disadvantages. One very big advantage is the know-how. So anything that happens to the code, you know how to fix it. You know when you see some behavior, you know where to pinpoint that behavior. You know which code is causing that behavior. There are no surprises, no randomly a dependency failing or doing something weird, because you wrote everything, you know exactly what is happening, why is this happening. And iteration means perfection. I think this is the most important for this Nich syndrome, is that because you own the code, because you wrote it, you can iterate on it as long as you want and make it as perfect as you want. I think it is very important in software where you need excellence or really good performance. If you were using some dependency and suddenly you will maybe hit a wall, okay, what is this dependency doing? How is it doing it? It's a black box. Maybe you can't really go into it. But if you own the code, if you wrote it, you know how to improve it, hopefully. And disadvantages. Disadvantages is time to deliver. It takes more time to write something yourself than just grabbing a dependency from somewhere. But also this kind of balances with the know-how, because yes, it takes more time to deliver, but you have the know-how to go into that code and improve it. So it may take more time initially, but then you move faster, I think. So this project that I'm talking today, I don't know if I should be talking about it because it's not finished yet. It's still a work in progress. There's lots to be done. There are lots of bugs. But I wanted to share some of the things that I found in the process, and maybe that would be helpful for you, and maybe you will get some ideas about that. Maybe you will write your own editors, maybe. So, also disadvantages, bugs and edge cases, because there will be lots of bugs in a new, fresh code that you haven't thought about, or edge cases you haven't thought about. So these need to be addressed. So these are the disadvantages of writing your own thing and not using a dependency. So building a code editor in the browser is the real theme of the talk. I don't think I mentioned it at the beginning, but if you knew the schedule, you would have known that it's a code editor. So my mistake, sorry. So building a code editor in the browser, what is the problems there? So you want to build a code editor, sorry. You want to build a code editor, okay. And where do you start in the browser? You try to find something that is already in the browser. So you find the text area. The text area is a nice editor, okay? It's full featured, it has copy paste, it has selections, it has undo, redo, it has lots of things. It's a decent editor, but it doesn't scale. And we want a code editor to scale. We don't want it to be slow. So maybe you will use content editable. That's another also option in the browser. Good luck with that. I think the browser is not meant for use cases like that. A code editor needs to handle lots of edge cases, I think. I think you expect your code editor to be able to open a file that is 100,000 lines long, or open a log file that is millions of lines long. I think you want your code editor to be able to do that. And that is very hard to do that in the browser, because you don't have the tools there. So browser code editors are hard to scale. Why? Because browsers are optimized for the common case and not for the edge case. Browsers are optimized, sorry. So browsers are optimized for the common case. Browsers expect a screen that doesn't scroll that much, has mostly inanimate content, and it performs really well for that case. When you insert a file that is 100,000 lines long, the height of the page will make the browser really, really slow. The content, if you just insert syntax highlighted content, basically just text, but with syntax highlighting into the browser, with these big files, it will become very, very slow. If you try to edit also that, it will be very, very, very slow. So how do we work around this? So we need to address all the edge cases. How do we address the edge cases in an environment that is optimized for the common case? How do we do that? So that is the issue. So there are two parts that are blocking us. One is the computation and one is the rendering part. The computation is not that bad because JavaScript and browsers and JavaScript is fast in the browser. JavaScript engines are fast. So computation, we can be okay. Rendering, not okay. Rendering is going to be slow in any case. We need to find our ways around it. So you want this these two parts, the computation and the rendering, to be faster than a single frame when you run at 60 frames per second, if you want 60 frames per second. So these two operations need to run less than 16 milliseconds at any case, at any work you do. That's a challenge, and that's why I was involved with this project, because it's full of challenges, and I like that. So what do you do? Benchmarking and profiling, everything. I was benchmarking everything while writing this editor. The test framework I wrote for the editor for testing my code, because also I also wrote the test framework for it. I told you Nick syndrome in the extreme, but it was a conscious choice, because I didn't want anything to be messing with my code, to be slowing down. I didn't want any surprises. I want to be responsible for everything. So in the test framework, I just decided, okay, I will add this feature that that will benchmark all my tests. So my tests are also benchmarks. That was easy because I owned the test framework. I could do it, and that was really good because I also added this feature that I could have two. I was actually the test case was designed this way, where I was injecting the dependency into the test case, so I could have the same tests, and have two different implementations. So I could benchmark, test, and benchmark two different implementations with the same API. So I could see which one performs better. I keep the one that performs better. I also wrote a small tool for the CLI that does some benchmarks. It's all in there in the repo. It's a monolith repo. It has all the modules inside it. Even the issues are a file inside the repo. Everything is in the repo because it was a solo project. So benchmarking and profiling. Profiling helped a lot. Profiling, the profile tools in Chrome and Firefox are incredible. Like you can see millisecond by millisecond what happens and how much do your functions take to execute. It was fantastic. You can see exactly what is going on, and you can find where are the bottlenecks, and you just go fix them. So I was kind of doing this profile-driven development, where I was running the profiler, doing some things in the editor, see how they perform, see which functions are slow, then trying to find solutions to make these functions faster. So how do I make these functions faster? I was hitting walls. I can't make it any faster. The way I wrote it, I can't write it any better. Like I don't have the knowledge to do it. So I started reading on data structures. Data structures are magic. This is the magic sauce in the editor and what made it fast. This is a nice URL. What are the lesser known but useful data structures in Stack Overflow? I have this open also. I don't know if you can see it. So the first answers is tries, Bloom filter, rope, skip lists, then spatial indices. And we use all the first ones in this project. We use the hottest, lesser known data types, except Bloom filter, but I have a plan to use Bloom filter also. It's a cool data structure. So we use the try, the Bloom filter not yet, the rope, and the skip list. And actually, I'm using a rope powered, a skip list powered rope. So what is the minimum for a code editor? What do you expect from a code editor to have? And what is the minimum you expect from a code editor to have? So you expect a scroll view. You can scroll and see your code. You expect a caret that you can move around with your keyboard. Input, you expect it to respond to input, mouse, keyboard. It needs a text buffer, something to keep all the text data inside. You need a syntax highlighter. You need, nowadays, all editors need syntax highlighting. You need a history, undo, redo. You need search and replace. You need autocomplete. And you need to do selections, copy, paste, these kind of things. So I consider this to be the minimum you need for a code editor. The rest, I found it like goes around this. This is the base. This is the core, and the rest is just chromium around around this. So the view. How do you make it fast? You need to minimize content. The browser, when it receives too much content, it will try to parse it, it will try to display it, render it. It will take time. So you need to find a way to minimize the content as much as possible. Even if you load 100,000 lines of code file, you need to not give that to the browser, because the browser will crash, will become very slow. So there are ways around this. One way is to use JavaScript scroll. JavaScript scrolling, basically, the scrolling is the first thing that slows down. You can see it that when you have lots of content, scrolling slows down a lot. But if you use JavaScript scroll, it does not, because it doesn't trigger that much the scroll event as it would by using native browser scroll. So the recent implementation, the latest implementation I have, is that I just read the wheel delta and animate the scroll, and that performs better than regular natural scroll, as odd as that sounds. So also you should not block for long. So the time it takes for the computations you need to do, they should be less than a frame in 60 frames per second. So this is how it looks. A little bit. The implementation is that the height, there is a div that expands to the height of the document, and we actually render what is the viewport can see only a small portion of the code, and we only render this part of the code that is visible, and plus some ahead and some below. The rest we discard it. So there's very little content always visible on the screen. That's one way of getting through that. The idea is that there's another limitation here, that the browsers can't go beyond a certain height. After that height, they stop rendering completely. They just render black. So that happens In this editor, it happens at around 1 million lines. 1 million lines of code, then it's black. It can't, at least Chrome cannot display anything more. So that's a problem. So I'm doing a refactor currently. So this will be, I am planning to make it so that it scrolls, so you are always at the same point in the physical space, if you can say it, in the browser. And you scroll, and it loops back, and you scroll again from the top, something like that. But I haven't implemented that yet. But that's the plan for that, because I need to be able to open files that are longer than 1 million lines. I want it to be a good editor. So the text buffer. That's the most critical component in the editor, because it couples with all the other components. The way you design the text buffer, it affects everything. Because we can't use, for example, strings for the text buffer. We can't use a single string for 1 million lines. It is impossible. So these are data structures that are used by editors. All famous editors use one of these data structures. One is the rope. The rope is essentially like a binary tree. A gap buffer. Gap buffer is essentially three strings. It is basically 3 strings with 2 strings with a gap in the middle. So when you edit in the gap, and then somehow you need to rearrange the buffer. Wikipedia explains this a lot better than me. Sorry, I can't. I don't have the ability to explain it. And piece table. Piece table is also a famous data structure. It is essentially, piece table is a log of actions. You log the insertions and the deletions, and you replay them to get the actual content. So I searched a little more, and I found skip list. Skip list is a very nice data structure. Skip list was invented in 1989 by William Pech. It is I consider it a magic algorithm, a magic data structure, because you use it and everything becomes fast suddenly. Again, I'm not sure how to actually analyze it. Wikipedia has better explanations for this. So famous implementations of the skip list is LevelDB, Redis, shortest search. And we can agree that these are fast software. So this skip list traversal, it inserts an element. So this is a new element 80. It tries to find well, you can see, I think. It does this traversal, which is really, really fast. So, I'm losing the mouse pointer all the time. So the other big problem is syntax highlights. So how do you write syntax highlights? Like you could use a parser, tokenizer, write an abstract syntax tree, and then draw everything. That would be very, very slow. So my approach was to use a parser that is already there. The parser that's already there is a browser, HTML. there's an HTML parser running in the browser. So I used regexps to search and replace tokens in the code that I need to color. I need to put colors there. So, for example, an operator will have a tag that is called operator, and inside it will be the operator, and close the tag, because browsers can handle custom tags, and you can style custom tags in the browser. It is not spec compliant, but you can do it. So I did it. So I tried that. It was really good. It was really fast. But then I thought maybe that's taking too much time for the browser. Maybe if I don't have a tag operator and I have a tag named just O, that's a single letter, maybe that will be faster. And turns out it is faster. Single letter tag names are parsed really fast. I could actually see the difference immediately when I changed from regular tag names to single letter tag names. I kind of doubled the speed just by that. So editing is another big issue. So the idea is to minimize redraws, because and only draw what is changing. There are essentially three cases when editing. You either edit in the same line, so you just change that line. You either insert a new line, so you need to push the content that is below that line, you need to push it downwards, or you delete a line, so you need to pull content up. So you need to I optimized for these use cases. I can show you. So this is the editor. You can see it. So I have the debug mode on, so you can see the layers. So as you can see, all the layers are being drawn, and when we scroll away, the rest are discarded. So it only needs to work, doesn't need to work a lot. So one optimization is that when you write the same line, only that line changes, and only the content of that line changes. We don't really redraw the line. We just change its content. And I don't know if you saw it, but the layer that I am trying to edit on top is like reduced. Like I'm not I'm just rendering the below part, and the upper part, I just reduce the height. That's an optimization for this case. And also optimize the enter case. When I hit the enter, I just push or pull the content. It's not being redrawn, it's just being pushed, which is really faster than redrawing it. So this is a 500,000 lines code. I think it performs really well. Okay. Autocomplete. Autocomplete is also a tricky issue that was solved by a data structure as well. Like I used this data structure called a trie or prefix tree, and it magically solves autocomplete. Because it's a tree, as you can see, when you try to search for TE, you will get the suggestions T, TED, then immediately. So this is really, really fast. And the way it's implemented is when you load a file, it indexes it initially, keeps the tree. When it sees new words, just inserts the new words into the prefix tree. I'm never deleting because it's fine. Like you might get an autocomplete for a word that is in the past, but who cares? Yeah, the point is that data structures are magic. They solve problems. Search is a problem. Currently, I don't have a fancy implementation for the search. Because it needs to be programmed on top of the skip list. The skip list it's not a continuous string, so I can't use index of. So what I do is every time the user presses Control F, tries to search, I concatenate the entire buffer and search and do an index of there. Index of, it performs quite well. It's not bad, but it's not ideal. I would expect to. I would want to actually search into the skip list directly somehow, but I don't know how yet. History also, undo, redo. How the way it's implemented is I just log all inserts and deletes and replay them when there is an undo. For a redo, I replay them normally. That's simple. So conclusion, browser rendering is slow. We need to find ways around it. We need more wheels. We need people reinventing the wheel more and writing more software. Even though if the software exists already, because it's good. It's good to have more games to play. Data structure are like magic. They solve problems. I am fascinated by the world of data structures. I am reading and reading. I wish I had time to, get more out of them. And profile-driven development. Profile your functions. Use the tools in Chrome and Firefox. Even if you just use Chrome, use also Firefox profile tools. They're quite good also. So, thank you. That's it. This is a repo for the code editor.
Got a few minutes for a few questions. Okay.
So, do you have any plans to implement this in Atom? Oh no, sorry, Electron.
Yeah. The plan is to finish this and then find a way to either Electron or
Node WebKit
or web-based. I was thinking also some CLI tool that I can just upload to a server, so I can edit files on the server using my browser.
Right, okay.
So
cool.
I can have like the idea was to have a Sublime quality software in the browser, so I can just jump into the server and edit files as if I was doing it locally.
All right.
So I want to ask you, you said that text area and content editable are slow and are not good. So what are you actually using for displaying the code? Are you using a div element?
That's a div element with custom tags.
Oh, with custom ones. So you're handling the insertion and deletions of the elements.
It is everything is handled. It is like game programming. You handle everything, all the stages.
And for the cursor, are you using the browser ones, or it's a custom made?
No, it's just a div that you move around.
Oh, it's just a div. So like in Google Docs, I think, because they are not using that as well. Okay, thanks.
Yeah, I have two comments. The first comment is you were defending not invented here because you think that can help you to understand better the code, and also because there was no surprises. No other option that I think that is also viable. I'm not saying that your approach is wrong. I'm saying that other options. Other option is leverage on the wonderful work that communities do around open source, and leverage on open source, and you can study the code, you can do pull requests, and you can build in the shoulders of giants. Sorry, I think that's my point of view, and I think that yours is also valid. The other aspect that I want to mention is I was very interested on this aspect of using regular expression for highlighting. How you manage cases like in Python, where, for example, a string can be in multiple lines, because with regular expressions there are going to be complexities of languages that you are not going to be able to cover. No?
Okay, this was a simplification. I use regular expressions in combination with some custom algorithms. So
Okay.
Because just regular expressions, they work for most of the cases, but not all the cases.
Yeah.
So I also use some custom.
Okay, then you, for example, can manage strings that span across several lines, right?
Excuse me?
You can manage, for example, a string. You have a string in Python or other languages where you can escape and then go to the next line. And with a regular expression, that's really hard to do if you don't apply it something more sophisticated.
I have a different tokenizer that handles this.
Okay, then you at the end use some kind of tokenizer.
Yeah, but not everything.
Okay.
I tokenize some things like the multi-line things. I tokenize just those.
Yeah, in the way that you describe it, I thought that you were using use regular expression and you discarded completely the other.
Yeah,
okay,
yeah.
That's great. Thank you.
Different browsers do different magic under the hood for optimization. Have you find any data structure having a better effect or a different effect across browser? Do you do much browser testing from Chrome or Firefox?
Really fast. I don't really spend too much time. I develop on Chrome, and I use my target group is Chrome users. Like I will give this and say it works good on Chrome. Use it on Chrome, but I test on Firefox also. I test a little bit on Firefox.
Mobile at all?
And mobile, yeah. The idea was also this to work mobile, and it works mobile. You can scroll really well. If you scroll really fast, because the scroll is GPU based, you might get some black screens because it won't have the time to draw the next code.
Last one, I swear. When you said that you're moving down doing enter, you are pushing down the code. So you're using just a transition and move the whole thing down.
Yeah.
Okay, that's clever.
Okay, thank you.